Guys, so as we talked about before, this is a cubic function. So, sorry, this is a cubed root function. So if you'll remember, it did something like that. Um, be very, very careful with this. So I think I want to start with the transformation. So that is going to give us a horizontal flip. And it's going to make our numbers kind of go weird. Um, so I even want to be careful on that. So let's start plugging in some numbers. So I want to just kind of think about what would make this 0. So if I plug in a positive 2, that's going to be negative 2 plus 2 is 0. So I want to have my starting point be 2, 0. And that's going to be my change in concavity. So that's going to be like this part right there. That's what it's talking about right there. Um, okay, so let's just kind of go from there, tread carefully. So let's go 1 away. So I want to try 3. So if I plug in 3, let's see if I can do this. Nope, it's not letting me. Oh, there. There. Okay, so if I plug in a 3 here, right here, that's going to be negative 3 plus 2. Well, negative 3 plus 2 is negative 1, and the cubed root of negative 1 is negative 1. Okay, so I like that. Let's go the other way. Let's do 1. So negative 1 plus 2 is 1. The cubed root of 1 is 1. Okay, so I want to put another number in for x. That's going to give me a nice cubed root. So let's do, I got it, 10. So negative 10 plus 2, that's negative 8, and the cubed root of negative 8 is negative 2. Okay, let's try 6. That would be negative 6 because negative 6, that's positive 6 plus 2, that's going to be the positive 8, which would give me positive 2. Okay, so let's kind of graph everything and see where we're going with this. So negative 6, 2, 1, 2, 3, 4, 5, 6, 1, 2, 1, 1, 2, 0, 3, negative 1, and 10, 2. 10, sorry, negative 2. Okay, so you can see that it's making this little sideways S here. Sorry, that's not exact through there. So that's exactly what we kind of planned on this being. So let's talk about the domain and we'll figure all this stuff out. So the domain is going to be negative infinity to positive infinity. The range is also going to be negative infinity to positive infinity because it goes out to the left and out to the right, but it goes up and it goes down. So that's where those are coming from. Okay, the y-intercept, remember we're going to set x equal to 0. So what would happen if we set x equal to 0? That would give me the cubed root of 2. So I'm just going to leave it like that. 0 cubed root of 2. If you want to put the yucky decimal in there, you can. But that's where it hits the y-axis. Okay, so we've got to figure out how this was shifted. So on a normal parent function, it would be right here. So notice it was shifted 2 to the right. Okay, now it goes against what we've talked about, but everything has to do with that negative sign. So just be really careful and just kind of think out of the box when you have a negative there because it does some strange stuff. Okay, so while we're at it, let's go. I want to jump to this one because it's very similar. I feel like this one is a little bit easier. So let's do this in a different color. We'll do this in blue. So we have nothing inside with the x, so my change of cavity is going to be 0, 3. I don't want to talk about domain range yet. My y-intercept, remember, set x equal to 0. So if I do that, I get 3. So 0, 3. Oh, that's interesting. So my change of concavity and my y-intercept is going to be the same. Okay, so transformations. I'm going to try to erase this again. Okay, so I have a vertical stretch of 2, and then up 3, and that's it there. So I'm going to put the 0, 3 in the middle, and then let's just kind of go out from there. So I'll do 1 and -1, 2 and -2, and see what happens. Okay, so if I plug in 1 here, I have 2, and 2 plus 3 is 5. 2, 2 to the third power is 8, 16, 19. Woo, that's going to be too big. Let's do -1. So -1 to the third power is -1. That makes it -2. -2 plus 3 is 1. -2, that's going to be -8, -16, -13. Woo, that's still too big. So let's go ahead and graph what we can, but just know that it's going to give us this look here. -1, 1, 0, 3, and 1, 5. 1, 2, 3, 4, 5. So notice it looks kind of like a straight line, but we need to know that it does something like that. Okay, so the domain, how far to the left does it go? How far to the right does it go? It goes out forever. So it's going to be -infinity to infinity. How low does it go? How high does it go? It goes also -infinity to infinity. Okay, that's it. And the last one is absolute value. So my vertex, my starting point is going to be -1, -2. And notice that this negative on the outside isn't going to affect that. So I'll go ahead and say vertical flip. Let's see, left 1, down 2. Okay, my y-intercept, remember I'm going to set x equal to 0. So I have negative absolute value of 1 minus 2. So 1 negative minus 2 is -3. 0, -3. 1, 2, 3, right there. And let's go ahead and start with my starting point in the middle. So -1, -2. So absolute values are linear. So this tells me it's kind of like my slope. So I'm going to go down 1 and over 1. Or you can just plug everything in and do it like we've been doing on all of these. So I know my starting point is here. So I'm going to go down 1 over 1 in both directions. Down 1 over 1, down 1 over 1. And just keep going until it looks like that. Okay, my domain, it goes to the left forever and to the right forever. And my range, notice it starts right here. So it begins in, or I guess starts or ends, however you want to look at it, begins in -infinity and it goes all the way up to -3. And that's it. And we are done with the graphing. Please start on your practice and have a great day.